Hey guys, it's Fowler again. So today's lesson is going to be on right triangle trigonometry. So trigonometry is a very big word, but it basically is the relationship between sides and angles in a right triangle in this case. So yesterday we did Pythagorean theorem with our right triangles and we found our missing sides. Today we're going to do basically a little intro to trig and set up our trig ratios. A ratio is just a fraction. And in this case, all right triangles have this ratio between their sides and an angle that corresponds to it. So I'm going to fill in the notes. The notes are going to be posted, a blank one. If you guys want, you can print it and go along with me. I'll try and go a little slower this time. Or you could just copy down like little things about it. So just the important stuff, like our trig ratios, that's important. What trigonometry is, that's important. And a little nifty way to memorize them, that's also important. And maybe a couple examples, all right? So I'm gonna flip you around. Pipe says hi. Did you see her? There she is. Say hi, Piper. Okay. And here we go. So, the basics. What is trigonometry? Trigonometry is the study of the relationship between sides and angles of right triangles. Okay? The study of the relationship between sides and angles of right triangles. So we have this little diagram here of our right triangle. So we've got angle A, angle B, and angle C is the right angle. And then we have these sides. So side little a, side little b, and side C. Okay? And then we've got these new words: sine, cosine, and tangent. You guys have seen these before because they are sine, cosine, and tangent on our calculator. Whoa, chill, babe. Sorry, she's a little bit loud. So, sine, cosine, tangent. Sine is the relationship, the ratio, of the leg opposite the angle to the hypotenuse. So if we look at angle A is right here. The side that's opposite of it, so if we drew a line, the one that doesn't touch it, is little a. I'm going to label him opposite, okay? So opposite of A, our hypotenuse is going to be the long side, so the one opposite of our right angle. I'm going to call him hype. And that leaves one thing left: opposite, hypotenuse, and adjacent. Adjacent is the side next to it. So for angle A, the opposite, the adjacent, and hypotenuse. So in this diagram, okay, sine, opposite over hypotenuse, is going to be A over C. Okay? Sine is the opposite of hypotenuse. Cosine of our angle A is going to be the adjacent over the hypotenuse. So our adjacent is little b, hypotenuse is still C. So over here, I'll write B over C. And then we'll do tangent. Tangent of our angle A is the opposite over the adjacent. So that'll be little a over little b. Okay, and these are just the ratios. We're just finding the ratios today. Your answers should all be fractions. So, there's a lot of words: opposite, adjacent, hypotenuse. I like to memorize it by a saying. It's not the most appropriate saying, but I think you guys will memorize it this way. And it's what I learned when I was in high school. So, sine, some old hippie, opposite over hypotenuse. Cosine, caught another hippie, that's the adjacent over the hypotenuse. And tangent, tripping on applesauce. That's the opposite over the adjacent. Okay, some old hippie caught another hippie tripping on apples. Because that's what hippies trip on. They trip on apples. Okay, so sine, opposite or hypotenuse, caught another, adjacent or hypotenuse, tripping on apple juice. So tangent, opposite over adjacent. We are just finding these ratios today because the angle, oh, baby's up, is going to be that. So if we do two examples. So example 1, we've got our right triangle here, and angle A is here. Okay, so let's see. The hypotenuse is going to be the longest side. It's always opposite of our right angle, so here's the hypotenuse. The adjacent angle, the angle next to A, is the 12, so I'll label A, DJ for adjacent. And then the last one is our opposite, and that'll be the 5. So we're just going to do A first. So sine, some old hippie, so that should be 5 over 13. And there's our answer. Okay, cosine, caught another hippie, so 12 over 13. And tangent, tripping on applesauce. So that should be 5 over 12. Okay, so that's with angle A. Now we're going to do the same thing with angle B, except for, angle C. Angle C is right here, and if you notice, the hypotenuse is still the same, but angle C has a different adjacent than angle A. So I'm going to use green for C. So C's adjacent is 5. Okay, and his hypotenuse is still the same, so I'll write hype there. And that means that 12 is going to be the opposite. Okay, so we'll do our same trig ratios, but we're doing for C. So sine of C, some old hippie, so that's 12 over 13, caught another, so that's 5, and then hippie is 13. So 5 over 13. And then tripping on applesauce. So that's 12 over 5. Okay. So if we look at these, is there any pattern you notice? Anything a little different? Well, let's see. 5 over 13 is right here. And it's also right there. If my pen worked. 5 over 13 and 5 over 15. 12 over 13 is right here, and 12 over 13 is right there. Interesting. And then the tans, 5 over 12 and 12 over 5. Same numbers, but they're flip-flopped. Interesting. I wonder if that works for all of them. So let's do another problem. All right, number 2. Okay, so we've got 9 and 12. Oh, and we're missing the hypotenuse. So what is one way we can find the missing side of that right triangle if we're missing the hypotenuse? You're right, Pythagorean theorem. We did it yesterday. So if we're looking for the long side, we're going to add the squares together. 9 squared plus 12 squared equals RC squared. So let's see, that's 81 plus 144. And I like to use my calculator. So let's see, 81 plus 144 equals 225, which is a perfect square. So we're going to take the square root because we know it's a perfect square. So we've got C is 15. So I'm going to write a 15 there. Okay, so now that we've got all the sides, let's start with angle W. We're going to do our trig ratios for angle W. So W is right there, and we're going to label our sides first. So the hypotenuse is long side, that's the 15. Okay, the adjacent is the other side touching it, so I'll label the adjacent next, which makes 12, the one it's not touching, the opposite. So sign, some old hippie. So that's 12 over 15. Now 12 over 15, we can simplify that fraction because they're both divisible by 3. And so it actually is 4/5. Okay. And the next one, cosine. So caught another hippie, so that's 9 over 15, which can also be divided by 3 to get 3/5. Okay, and the last one, tan. Tripping on applesauce. 12 over 9, which we're going to simplify to be 4/3. Okay, now I'm going to label my other sides with respect to angle x, because we're going to look at angle x next. So I'm going to circle my x. The hypotenuse is still the same. The adjacent this time is 12, so I'll label the ADJ. And that means the opposite is 9 for angle x. So let's start with sine of x. Some old hippie, so 9 over 15, which we can simplify to be 3/5. Oh, look, that's the same. Okay, cosine, caught another hippie, so 12 over 15, which does simplify as well to 4/5. Ooh, interesting. Same thing as that one. And then tangent, tripping on applesauce, 9 over 12, which can simplify to be 3/4, which just flips over that fraction bar. Interesting. Sweet. That worked again the same way. Huh, who'd have thought? So let's do the last one together, and then that'll be it, and you guys are gonna do an assignment on this as well. So this time, we've got our triangle, we've got the right angle here, which makes this guy right here the hypotenuse, and we're missing the third side, or we're missing one of the little sides. So since we have the hypotenuse, and we have a leg, we're going to subtract the squares this time to find the missing one using the Pythagorean theorem. So 34 squared minus 16 squared is going to equal our b squared. I'm going to call him b. So I'm going to type this in the calculator because I know we're going to have some big numbers here. 34 squared minus 16 squared. Okay. So we've got our b squared equals 900. We'll take the square root of that to get our side length to be just 30. And that makes sense because our hypotenuse is 34. This one's smaller. Now that we have all the sides, we're going to set up our trig ratios. So angle L is first, so I'm going to label my stuff with respect to L. So L's right here, the hypotenuse is right there, and that makes which one are adjacent, the 16 or the 30? You're right, it's 16. Okay, because that's next to our angle, and that means 30 is the opposite. So sine of angle L, some old hippie, so 30 over 34. Cosine, caught another hippie, 16 over 34. And tangent, tripping on applesauce, 30 over 16. Now, looking at those fractions, are we done or do we need to simplify? Yeah, you're right, we do need to simplify. So you could do two ways. One, you could just type it into your calculator. If you have one, you could do it online too. And I just do alpha y equals, let's see, 30 over 34 will simplify it for me to get 15 over 17. Okay, or you could just figure out what they have in common and divide. Like these two, we'll just divide it by 2. 8 over 17. And this one, we can divide it by 2 again. 15/8. Okay, now looking at that pattern, what do you think will be sine of m? Let's see, sine of m. The second sine, it always was the cosine of the first angle. So I'm thinking it's probably going to be 8/17 when it simplifies. Let's check. So angle M is right here. Let's see, hypotenuse is the same. Now the adjacent is going to be the one next to it, so it'll be this guy here, our 30. And the opposite is the 16, because that's the guy left and it's not touching your angle. So some old hippie, 16/34. Does 16/34 simplify to equal 8/17? It does. Check. All right. So using that same pattern, what do you guys think cosine of m is going to be? Yep, it's 15/17. Let's see, cosine. Caught another hippie, so 30/34. 30/34 does simplify to equal that 15/17. And then our tangent is going to be what? 8/15 is the correct answer. So when we're doing trig ratios and you're just finding the ratio, okay, you're going to get a fraction every single time, okay? Doesn't matter. You will always have a fraction. Simplify it if you can, all right? And that is your final answer. I have a practice for you guys to do on this, all right? And I'm going to put it and assign it for you guys, and I would like it done. I also want you guys to comment one thing on here, one fact about trig. It could be any fact you know. You could look it up and just surprise me. I need one fact in the comments, okay? Thanks. Bye, guys. Miss you.